Welcome to Emilak Online Tutorial. Now, this is a question in elasticity, and we are told to calculate the stress on the wire and the strain in the wire. Now, first of all, let us recall the formula for stress. And for stress, it is force all over area. Now, while that of strain is the extension all over the original length. Okay, now how do we get the area? Now, for us to get the area, we need to determine what shape does the material takes it from. Now, a force of 40 Newton, which implies that our force is 40 Newton. Now, applied at the free end of a wire. So since it's a wire, then it takes the shape of we'll have to take, since this is the wire like this, so we have to take this shape, which is in form of what? A cycle. So now the area here will now be pi r square. Now we are given an extension E, which is 0.24 millimeter. Now we have to convert this to meter, and by so doing, we have a extension will now be 0.24 times milli. Here implies 10 raised to the power of minus 3. Okay, and take note that here, let's put this in the right index form. That will be 2.4 times 10 raised to the power minus 1 times 10 raised to the power minus 3 meter. So at the end of the day, you have 2.4 times 10 raised to the power minus 4 meter as the extension. Alright, so is there another thing we are given? Okay, I guess the original length, which is L, is given as what? 3 meter. Now, first of all, let us now calculate. Okay, the diameter also is 2 millimeter. Okay, diameter, which is D, is 2 millimeter, and diameter is 2r. Okay, and for us to get our r here, it means D will be divided by 2, which implies 2.0 mm all over 2, and this will give us 1.0 mm. And converting this to meter, we have this is 1.0 times 10 to the power minus 3 m. Okay, all right, to that end, now let us now find the area. Our area here, that will be pi r square, which will give us pi, you have 3.143, then times our radius, that will be 1.0 times 10 to the power minus 3, all raised to the power of 2. Now this will give us 3.143, then times, it's now be 1, because 1 raised to the power of 2 is 1, then times 10 raised to the power, now by indices will be minus 6. Okay, all right, and our radius here will definitely be 3.143 times the whole of this is just the same thing as 10 raised to the power of minus 6. Okay, all right, so let us now apply that. So for the stress here now will now be force, which is 40, then all over the area, that will be 3.143 times 10 raised to the power of minus 6, which is the same thing as saying 40 times 10 raised to the power of 6. That's when you bring 10 to the power of minus 6 to the denominator, to the numerator, this negative sign will become positive, 3.143. all right, and when we tend to punch our calculator here, we tend to have 1.27 times 10 raised to the power of 7 Newton per meter square. Okay, so that is the value for the stress. Now for the extension here, for this strain, which is extension all over the original length, and the extension is given by this. So you have 2.4 times 10 to the power minus 4 all over the original length, which is 3. Okay, and 3 here, 3 in 2.4 will give us 0.8. Okay, so and as such here, the strain will now be 0.8 times 10 raised to the power of minus 4, which could also be 8 times 10 to the power minus 5. Alright, it has no unit because the extension is in meter and the original length also is in meter. Alright, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and chemistry. Thank you and God bless you.